Thanks. So I'm just going to jump right in, gonna give a little bit about me. I am a consultant for Optiv Security. I try to pose as a full stack developer some of the time. And that's kind of led me down to creating this tool. And this all kind of arose from really doing like evasive testing. There's a lot of manual procedures that go into it, spinning up, taking down services in various content delivery networks, trying to hide source of attack and trying to kind of bypass a lot of these controls existing on the perimeter and on the internal networks that will detect anomalous activity such as port scanning, data exfiltration, and stuff of the like, as well as you need to protect this infrastructure from potential investigation from the defenders looking at this traffic. So this kind of led to me thinking more about this. And as you all know, you might have seen tools like Red Baron and the like come out that really involve more long-term persistent red team infrastructure. Stuff that you're going to keep up for a long time, you're going to manage, and you're really going to harden down and kind of do your whole engagement from. But the whole idea that I kind of went with is I'm looking for ephemeral infrastructure, stuff that will not last more than even so a day. I want something that'll come up, come down, so that there can really be no correlation to its traffic and any of your activities going through a red team activity. So any investigation, it will be that that IP is no longer live, or that IP now belongs to someone else on this various cloud services that we're using. This leads to a very small footprint, so that, again, it's very hard to correlate what's going on if you have these type of services that aren't lasting very long, aren't doing very much, but combined, they're getting your whole goal accomplished, but making it much harder to detect. And I have the link here for the GitHub, the teaser site. The code isn't quite live yet. I was trying to get it ready, but it's still a little bit hacked together in a way. It needs a little bit more fleshing out. We'll go through a demo later, but if you want to follow that GitHub site, then you can go ahead and get it as soon as it's released. So one of the main components about this is managing a cross-provider platform. We want a single interface to manage multiple cloud providers and their various VPS and VPS services, API gateways, firewalls. We want all that stuff in one spot. So this tool really aims to give you that singular view of, let's say I spin up 80 servers and they're all distributed between Google, AWS, and DigitalOcean. I don't want to have to go through each console and manage each one individually. I want to be able to look at my entire landscape of my infrastructure and be able to make decisions on that, rather than trying to have to correlate them all together and manage them individually. Though this kind of plays into, I can deploy, destroy, start, and stop instances on demand. That being said, it really makes it, again, easy to manage multiple cloud providers. Also, I can easily send and get files from these servers, and I can drop into a command shell on any one on a whim, just by sending one command in my, basically in the tool interface. Furthermore, I've added protections that you can put in place. Basic one is firewalls or security groups that you can place on individual servers. So let's say I have 10 servers and I want to open one of them up and run Apache on it for some type of phishing engagement. I can open up just port 80 on one of my servers and have that maintained as my phishing infrastructure. Also, you can add in redirectors that will redirect based on certain rules. Let's say that if you don't meet a certain user agent, then that will redirect the request to wherever you want to go. This is probably one of the biggest things in this framework that is really useful for an evasive test. let's say you're running a port scan. You don't want to run top 1,000 ports from one server if you're doing an evasive test. That's going to hit every single IDS and IPS there is going to notice that's a port scan, block that IP, we're done with. What you can do with this tool is you can distribute those jobs among your entire infrastructure. And then they are tasked with very small jobs, making 1 or 2 requests to your targets, and then bringing all that data back and correlating it back on your end, on your central endpoint. So that way you get all of the data, but when a defender is watching their logs, it looks like normal internet traffic, a port here, a port there, and it doesn't necessarily look like someone is port scanning unless they're really, really looking for it. And this yields for future developments where I want to be able to distribute commands across this entire infrastructure. Let's say you're doing directory brute forcing. You want to split up that word list and split up the job among all of these hosts so that the job can be done quickly, efficiently, and relatively quietly because the traffic isn't coming from one endpoint. Another thing is, speaking of proxying those requests, you can create SOX proxies on any of these hosts. So theoretically, I could spin up 40 hosts, put a SOX proxy on each one of them, and then use proxy chains to send each request through a different proxy. This is simply another method of kind of distributing commands. It's a bit slower than that distributed command example I went through before, but it still achieves a similar effect of each request is going through a different proxy. And stuff that can't go through proxy chains, there's also SOXD configurations that get printed out as well in the tool. This kind of plays on the other one. These are use cases for those proxies that you're using. So you can use it for discovery and exploitation. You can separate those activities. You can have one SOX proxy that's for your discovery, one SOX proxy that's for authenticated discovery, and one that's for pure exploitation. So that when they're going back on the server logs, it won't be the same server doing the entire attack chain. So it will be hard to correlate who's doing what and following that narrative from an IR investigation perspective. This also includes to brute forcing, and if one of your servers gets blocked from spidering and a WAF detects that activity, blocks that IP, it's really not an issue. You can bring it down, bring it back up, and now that that server is no longer blocked with a fresh IP. Furthermore, I implemented an API gateway. You can't see it that well on here at all, but the idea is that Amazon API gateways allow you to configure an endpoint that you can hit, and it will make a request on your behalf to another server. So I have an API gateway that will make a request to a certain endpoint, but each request from that API gateway generally has a different IP cycling through about 500-ish per region. So it allows you to password guess. The screenshot I have up here is guessing an OWA portal. If anyone's been on a red team engagement, they know OWA guessing is an easy go-to. But this allows for the OWA guessing to be distributed across these services, and coming from different IPs, it again furthers that the difficulty in detecting this kind of activity and tracking it to a single endpoint. In this way, you can separate yourself from the brute forcing itself. A big thing I wanted to add in here, because that's something that I've been using a lot more, is domain fronting. For those of you who don't necessarily know what domain fronting is, originally it was a technique that the major content delivery networks used to bypass internet censorship. So in Egypt during the Arab Spring, they used domain fronting to make signal available to users in Egypt. And that made it so that you could request google.com, but via the host header, you could actually still access signal, even though that signal itself was blocked. So a lot of the major content delivery networks made signal available, and that way they could still access signal, still have communication going on inside this country with a restricted network. The reason that they did it is because stopping it looks a whole lot like turning off the internet. So if you're going to stop domain fronting, you got to block a good portion of Amazon, a good portion of Google, Azure, basically any cloud provider out there. And if you're turning off Azure, Amazon, and Google, you don't really have much internet left, right? So really, the thing is that people hear this and they're like, so what? The reason domain fronting really matters, and especially in terms from a red team and blue team perspective, is that it's able to bypass a lot of egress controls. So if you're doing domain fronting through Google and with a Google endpoint, your actual TLS and SSL negotiation happens with that Google site that you're requesting. So if you're requesting www.google.com, your TLS negotiation is happening with Google.com. It's not till it gets to that Google infrastructure that it is routed to your App Engine instance, which is acting as your redirector. And this means that this is now encrypted with HSTS, and this makes SSL stripping very hard. And I am not aware of any. I'm not really big on the SSL stripping and the SSL interception technologies, but I'm not really aware of many, if any, that can actually strip HSTS encrypted connections with Google. And so a lot of companies just allow Google outbound. It's not something that they intercept on their SSL appliances. Then the big thing is that it's not only restricted to Google. You can do this over Azure. You can do this over Amazon. You can do it over Akamai, I believe. And the possibilities are endless because a lot of these major content delivery networks, domain fronting is a way that they ensure robustness of their platform. So you can really leverage it in a lot of ways in terms of an attacker. And this kind of leads me back into the tool of, right now you can deploy Amazon and Google-based cloud domain fronts. And this allows you to set in your source and your endpoint and click and you're go. It's very simple. This really arose from the fact that it's kind of tedious to set up multiple domain fronts, and just being able to manage them all in one spot, set them up on a whim, was really, really appealing. Furthermore, it allows you to restrict access based on, let's say, subnet or IP, and also even user agent. A technique I really like to use for user agents, that if you restrict it based on user agent, then when you make that request to the domain front, you can put an extra space in a valid user agent, and so any investigation will look like a valid user agent, except for that extra space is actually what the regex is keying on. So you will not be able to access the domain front, and the reaction from it will be, it'll redirect you to wherever you determine. So if I'm posing as inbox.google.com, I'll have my redirector based on that user agent string redirect to inbox.google.com. So let's say any defender that's investigating, they type it into their browser, they go to the AppSpot instance where my redirector is actually hosted, and they get redirected to inbox.google.com. So that's really perplexing. So they may just think this is just some Google craziness that's going on. So now I'm going to go through a demo of the tool itself. Okay, let's see if this, okay, that's not looking good. Give me 1 second. Let me change the display on here. There we go. All right, that better? Can everyone see? Okay, so the tool itself is built with Go, and it's built via the Go specifications. And I will, just talk through it right now. As you can see, we are deploying the cloud providers. It currently supports AWS, DigitalOcean, and Google. I'm working to support Azure currently and more cloud providers in the future. So here, I'm just deploying 4 servers, and it will divide them between the 2 cloud providers in any regions that I choose, have in my configuration file. It takes a little while to initialize all the instances so I can do all the operations on them. But as you can see here, we can deploy, destroy, start, stop, list them, drop into a command shell, add a SOX proxy, create a domain front, distribute an nmap scan among the instances, print out the proxy configuration for proxy chains and SOXD, send files, retrieve files, and set up a firewall. I'm working on, in the future developments, of importing existing cloud infrastructure so that your firewalls, domain fronts, and your VPSs can be imported when the tool initializes, so that any existing infrastructure you have in there will be manageable from this interface. As well as this interface was mainly made for this con, so forgive any things that are a problem with it, because it was really just hacked together in that regard. And I'm working on more of a web-based interface where you can get more of a visual view of what's going on. So as we wait for this, I'll kind of go into the framework that is being used. It's built on Go, and via the Go specifications, everything is a package, right? So all the Amazon stuff, Google, DigitalOcean, all that stuff is package-based. And that means that if one of y'all wanted to go out and write a tool that deployed Amazon instances and did some management of them, you could simply go import the package from this project and use the deploy EC2 feature in your own project. So that's why it's a framework and not necessarily a tool itself. So it's not restricted to using the entire framework. You can import the DigitalOcean, you can import the just cloud fronting. So anything that you wanted to do on your own, you could simply import it and just run it inside your own program. So that's why I really wanted to have a package-based system, so that if you wanted to just take a few of these and kind of make it into something your own, that's something you can go ahead and do no problem. So all these functions are already written, and you don't have to wrestle with this tool. You can really kind of do what you want if you're looking for something a little bit different. But now we have, our servers have been deployed, and we're going to go ahead and list them. As you can see, it gives you the type, the IP, the region, and various states of what's going on. So we're going to go ahead and add SOX proxies. And as you can see, we created SOX proxies, added all the servers to the proxy, and started on port 8081. And then now it'll increment through each one, and now I have 4 SOX proxies. Then we printed out the proxy config, so you could copy and paste this into your proxy chain's config file, or you could use this in SOXD. Also, it's not limited to anything. If you had 80 servers, you could spin up 80 instances of a SOX proxy if you so desire. So now we're going to go ahead and kill one of the SOX proxies. And for the server 1, so now, as you can see, the SOX value is NA. So that means the SOX is not live for that host. So we're going to drop into that host because we're going to want to make this host like a web server, right? So we're going to open up a shell, and just a little confirmation of where I'm at. You got the ifconfig. And so what you would be doing here is you would go in there, you would make manual changes to the server that you would want, and let's say you want to install Apache, kind of do some custom requests on it, or just anything customized that you want to do to it. It'll be easy just to drop in and do it manually. So there you have it right there. And now we're going to make a firewall for that server that we want to act as our web server. So we're going to create a 443 inbound, and we're going to make it globally accessible. And then we're going to name the firewall. and then we're going to list the firewall that we have active. So now, as you can see, we're able to create a firewall just for that server. So we're not creating anything like a security group that has everything in it. Just this server now has 443 inbound, and I can make it a web server and kind of do what I want. Something I'm looking to add in the future is a bit more customizability in terms of deploying web servers. I do have something on my GitHub right now that will automatically deploy a Let's Encrypt cert to a server of your choice. So that's going to be implemented in this in probably the coming weeks of being able to deploy a web server, deploy a Let's Encrypt cert just on the go in one command. So now we're going to create a domain front. And we're going to do a Google domain front. And where we want it to point to is essentially where we're going to where the redirector is going to point to, our C2 server, for example. So I've been going through all those, and we're not going to restrict based on user agent or subnet, but that is an option to kind of, as I was talking about before, redirect based on that user agent or subnet, so you can kind of provide a little bit more defensive measures to this domain front and not make it really globally accessible. And we're using gcloud here. And so I'm going to go ahead and make my AppSpot instance. So now what's happening is that it's basically updating the App Engine service that it's using, because with Google domain fronting, you use an App Engine service that you can request any Google URL, and you set the host header to your AppSpot URL provided by the service. So now that it's complete, we're going to go ahead and list the domain fronts. And so as you can see, this the URL, if we request, let's say if I did a curl command and set the host header to inboxa90.appspot.com, but the URL that I requested was inbox.google.com, it would actually be redirected to https example.com. So how we use that in a red team situation is, let's say I have an agent inside basically on a restricted corporate network where they do kind of a web content inspection outbound. So what's happened, or web content inspection. So the thing is that when they're reaching out, they're actually making that request, that negotiation with inbox.google.com. And so as my agent has its traffic, the data it's exfilling is actually being encrypted with a Google certificate, going out to Google's infrastructure and then getting routed to my C2 infrastructure. So that means that this malicious agent, a Trojan or whatever, is now communicating with Google.com from an outsider's perspective, but is being routed to my C2 infrastructure. And I now have a robust encrypted C2 channel with HSTS via Google.com. And I believe that is the end of the demo right now. And then let me just move on to the future improvements that I'm looking to make to this in the coming weeks, or adding more cloud providers in a web-based graphical interface, so you can get more basically more of a visual view of what's going on, what you're doing, kind of more graphs, and just a better interface for the user to deal with this. I'm also looking into adding Docker containers and Vagrant VMs in order to push them up in the infrastructure, make it a little bit easier to install dependencies and things like that. Also working out the distributed commands and adding more cloud services such as AWS Lambda and integrating those more into the platform. Furthermore, I'm looking for a little bit more robustness in the way I'm taking input and the way I'm deploying things. So it's still very immature, but right now I'm using it in the wild, and it's worked out pretty well for me on engagement so far. That was the end of my talk. I will open it up for questions if anyone has any. Yeah, for sure. I mean, I'm definitely like Lambda functions and that kind of idea is definitely in the works right now, because that's much like what I'm using for Google App Engine. You can just deploy a single Go script into Google App Engine and do that. But Lambda is definitely in the development pipeline for sure.
Your domain frame, so the client is actually connecting to Google domain and doing a Google search from their website, but they're using a different host header in the HTTP request.
Yes, but it's because it's wrapped in the TLS.
Oh, I know.
Yeah.
Google doesn't care.
No, see what happens is that it reaches Google's front-end infrastructure, and then now that URL is gone, and then it redirects based on the host header once it gets to Google's infrastructure. It's supposed to match if it.
They don't care yet.
No. Yeah, they do not care yet. Yeah, exactly. Because I mean, I forget which RFC it is, but the RFC that defines the host header, and if it's a compliant proxy, it'll rewrite the host header and thwart that. But because it's encrypted with HSTS, it's really, really hard to intercept that SSL connection, right?
Right. They should just put on their website, they should be looking at their logs or something and determining that you ask for something that they are not serving.
Yeah, but like I said, that's actually, it's part of what adds robustness to the internet, because basically making domain fronting work is they can ensure availability in a way. So it's one of those things that until it really becomes an issue, I doubt they're going to do anything about it. Even then, I'm sure that if they get like a subpoena or something like that, they'll just give the owner of that instance to whoever. So I'm not sure that I'm not sure it'll ever become rampant with script kiddies enough that it'll actually become that big of an issue. But if it does change, then I'm going to be very disappointed. Anyone else? Oh yeah, for sure. If you wanna collaborate, just you can get in touch with me via like LinkedIn or Twitter. It's at Mike Hodges, and we can flesh something out. I'm very, very new to the whole collaborative development, and my wife is actually like teaching me everything about not pushing to master and using branches and everything. But yeah, I'm definitely open to it because I think that it would add a lot of value to it, because the whole idea is I want to create more of a framework that people can use and not just restrict them to the tool, and kind of give everyone this capability of kind of more of this is DevOps-y kind of pen testing and kind of this red team framework. What do you mean? With the Google domain fronting, yes, because it's encrypted all the way to the AppSpot instance, and then it's kind of like in the Google domain fronting, I'm using more of a reverse proxy on App Engine. In the Amazon cloud or domain fronting, I use CloudFront. So both of those, if you set an endpoint for HTTPS, so it's reaching that redirector, and it's being inside that redirector VM. It's being decrypted and then re-encrypted when it negotiates with your HTTPS encrypted C2 server. So if they were inspecting the contents of the VM, they could see what's going in. But then again, if they're inspecting contents of VM traffic, that's kind of a no-no if people were figuring that out, right? Great question. So, me, a colleague of mine, and a couple of more of the network architecture guys at Optiv, we actually did a study on this and ran this domain fronting and ran it through various. We basically ran it through Wireshark and sent the PCAPs off to them. And what you find is that the ratio to certificate negotiations and requests is abnormally high. So that is probably your best indicator that this is happening, is that there is a new certificate negotiation each time it beacons out, right? So that is one way. You certainly could, like, there are agents where you could build in reusing that connection, but as of right now, that is probably, in my opinion, the best way, because it's not necessarily feasible to strip SSL and all of this, but I would say that is probably your best indicator. If you want to get more information on this technique specifically, the Optiv blog we did a write-up on this, and also we had the more of our defenders come in and do their write-up on what they saw and how to detect it. It's called, I think it's Egress and Evasion in Restricted Networks Part 2. So if you want to go check that out and kind of more information about this, I would highly recommend taking a look. It's a pretty good collaborative piece between red and blue on that one. Okay, I'll wrap it up. Thank you for your time.